So alternatively, you can actually do this with quantitative data. So let's just have an example here how you do this with quantitative data. So if you're doing quantitative data, you can have student. So you have student. So let's say you have student marks. So let me just bold this column so that you can see it's a name column. So you have student marks. So let's say you have run between. So let's say you're doing a test between 0 and the marks range from 0 to 50. So you have. So the run between function basically gives you a random value. So let's just go. We need 50 of this, so you have to go all the way to 51. So yes, you have 51. So you have 50 of these. So then we have what you call the class definitions, the classes. So the classes are going to give you. So you have class. The first class is going to be 0 to 10. Then the next one is going to be 11 to 20. Then the next one is going to be. So you want to format this so that they are text. So you want to format this cell so that you have text. So you have 0 to 10. Then you have 11 to 20. Then you have 21. Wait a minute. So I said you want to format this as text. Yeah. So then you're going to have 11 to 20. Why does it keep doing that? So let me just try again. I want to format as text. So we said you have now 10, 11 to 20. Oh, it insists. I'm not sure what I'm going to have to do here. So I want to format the cell, and I want to format it as text. So 11 to 20, then 21 to 30, then 31 to 40, then 41 to 50. So these are the classes. So there's something called a class width, which is the number of unique values within a class. It is standard to have the same class width. Yeah, to have the same class width. So here we already have a problem because the class width is going to be the upper limit. The upper limit is the higher value here minus the lower limit. Yeah. So the upper limit here is 10 and the lower limit is 0 plus 1. So 10 minus 0 plus 1 is actually 11. So the first class that we have here is actually going to be wider than the next class, because here the next class is actually 11 minus 20, which 20 minus 11, which is 9 plus 1, which is 10. So you have 11 unique values here, but you only have 10 unique values here. So to correct this, usually we want to have the class width to be the same. So that's going to be 0. Then you want to have the next one to be 10s. So it's 10 to 19. Then you want the next one to be 20 to 29. Then you want the next one to be 30 to 39. And you want the next one to be 40. You do the 40s. Yeah. So if you do it like this, then your class width is exactly 10 for all the classes. But sometimes this is not practical. So for instance, these are student marks, as you can see. So the highest value is actually 50. Yeah. So the highest value is actually 50 because the function we used was run between 0 and 50. So you might find in some cases the classes are unequal, because if you do 40 to 50, then this last class actually has 11 values because you have 40 to 50 inclusive. So the class width is actually, you have 11 unique values from 40 to 50, and the rest of the classes actually have 10 unique values. So it depends, really depends, but typically you want your classes to actually be equivalent. So if I want to correct that for our data, I can say that the last student should get 49, the highest mark is 49. But of course this is not so I'm just being mathematically accurate, but not necessarily accurate in the sense of the real values. Yeah. So 40 to 49. So the upper limit here is going to be 0. It's going to be 9 rather. So we have an upper limit of 9. We have an upper limit of 19. We have an upper limit of 29. We have an upper limit here of 39. We have an upper limit of 49. So if you do this exactly, mathematically correctly, then your class widths are supposed to be the same. Then the other thing you have to notice is that you can see that between consecutive, the difference between consecutive lower limits, you can see the lower limit here is 0 and the lower limit here is 10, is the class width. So 10 minus 0 is actually 10. 19 minus 9 is actually 10. If you look at this, 9 plus 10 is 19, 19 plus 10 is 29. So the difference between consecutive upper limits or consecutive lower limits is actually the class width. You might be interested in getting the central point. So the central point is actually useful if you're going to do certain calculations like the average of group data. So if you're doing the averages and the central and you're doing the variances, essentially if you look at the central tendencies of these group data, you're going to have to use the central point. So the center point or the midpoint for a class is actually the average of its limits. So the average of 0 and 9 is going to be 4.5. 4.5, then the next is going to be 14.5, and the next is going to be 24.5, the next is going to be 34.5, and the next one is going to be 44.5. So actually you have this. So this is what you get for the central point. So if you want to construct a frequency distribution, we need to compute the values that are within a particular range. So here actually we get the here we actually get the, you use the frequency function. Remember, when I used categorical data, I used the counting function, but in this case use the frequency function, and the input is going to be a set of arrays. If you look at the constructor or definition, it's going to be the array of numbers of values. Then you're going to have the array of the upper limits, yeah, and that will give you the value. So that's the number of values which are between 0 and 9. So let me see if I sum this. I can see already it's not giving me the right value. So what could be the issue? Maybe I need to, I think I need to fix this. Maybe I need to fix this. Let's just see what's going on. I need to fix the values because the formula keeps on shifting. So if I fix the formula, what do I get? So this value still, because you know the sum, the total frequency should be 50. So there's something not right. So let me see what happens if I get rid of this clutter here. I need to get rid of this clutter here. Get rid of this. What happens? So this give me 35. How about if I get rid of this clutter here? So it's a good idea. Sometimes the formula may not work as expected. So it's giving me 173. Looks a bit crazy. So I'm determined to find out what the problem might be. So that's the frequency function. So that is A to A51. Just give me 13. A2 to A51. and B. So we have B2 to B6, then we have A2 to A51, then we have B2 to B6, that gives me a 10. So we have A2 to A51, then you have B2 to B6, then we have A2 to A51, then we have B2 to B6, and we have 55. So could it be that the values are changing? So let me try to fix this, see what happens. Copy. So now I've fixed the values. A2 to A51, B2 to B6, A2 to 51, B2 to B6. So I have 55. 55 doesn't really make a lot of sense because I have 50 values. Unless so what could be happening? B2 to B6, B2 to B6, B2 to B6, B2 to B6, and B2 to B6. We don't really have any overlap, so so it doesn't seem to work. Maybe we try. You can actually get values B. So this is not working as I expect, because I expect the total to be 50. So maybe we try using the cumulative. We try to use the cumulative form. I think there's a cumulative form. We do frequency, you get this, then we have the just B2. So this is giving us the cumulative form, I think. Then this is going to be B3. Let me just see if this is correct. Then this is going to be B4. So the frequency function doesn't seem to be reliable. It's not giving me the value I expect, right? So this is the cumulative form, yeah. So you can manipulate the cumulative form. So if I wanted the ones which are actually in between, it means I get that minus that, I get this minus that, yeah. So all I have to do here is to get, it's a bit more work. So this is a bit more work because I'm using the cumulative form. So I wanted to get minus B2, then it's gonna be that minus control. Oops. So sometimes the function actually doesn't work as expected. So it's always good to check, not to take it for granted. So this was up to B2, then B3 minus B2, then that is B4 minus B3, then that's B5. So I'm going to just fill this in, then explain in a bit. Minus B4, minus B4. Then this is going to be B6 minus B5 minus B5. So this is I use the cumulative form. You can have the cumulative frequencies. So that I haven't spoken about cumulative frequency yet. So this is the frequency distribution. You can see that our total value is actually 50. Yeah, because this we have 50 entries, right? I haven't spoken about cumulative frequencies yet. So cumulative frequency. Let me first talk about the. Of course, you could have the relative frequency. You can have what you call the relative frequency. So relative frequency, we already know what this is. It's the frequency as a proportion, right? It is the frequency as a proportion. So it's going to be whatever this is divided by the sum of so it's going to be divided by the sum by the total frequency distribution. So you're going to have you want to fix it, then you can easily, you know, copy and paste the formula. Then so that is the relative frequency. Then we said you can also have a percent frequency, and of course this should sum to 1. If we check, if you've done this correctly, this should sum to 1, right? It's always important to check, as we've seen sometimes the formulae don't even work correctly. So we say this is the sum of this, so that should give you 1, right? Then the percent frequency is simply the relative frequency by 100, and this should also give you 100 as the sum, right? So you have, because the sum is whatever you have over here, right? So that is the that is what we expect. So going back to the of course you can visualize this using a pie chart and or a frequency table, or a bar chart, as I explained before. But then going back to the issue of the frequency, right? Because the frequency, I should have used the frequency function. If it was working correctly, it should have given us a total frequency of 50, but it wasn't working correctly. So what I did was to use a cumulative frequency. So I've not yet explained what a cumulative frequency is. So if I clear, so if you look at the cumulative frequency, the cumulative frequencies, so the cumulative frequency will give you the frequency up to that point. Yeah. So for instance, here we have if we have the cumulative frequency, the frequency from this range. So we have the frequency from this range. So let me fix the range so that I don't have to keep on editing. From this range to this point, to that point, right? So I'm getting all the values for the first, up to the first class. Yeah. Then if I want to get the values up to the second class, yeah, because this class had 11 and the next class has 10 values, so 11 plus 10 should give me 21, right? If I go to the next class, I get a cumulative frequency of 36. So that means there are 36 unique entries in the first 3 classes, and so on and so forth. So the last cumulative frequency should actually be the total frequency. Yeah, should actually be the total frequency. So that is the cumulative frequency. So because the frequency function wasn't working correctly, the categorical form isn't working correctly apparently. So what I did, my hack was to use the my hack was actually to use, if I expand this, you may not be able to see it up in the formula bar, but if I expand this, you can see, well, what I did was actually to hack it and use the cumulative form. So for instance, if I want to know the number of values in the second class, I can use the cumulative form. I get the cumulative frequency up to that point minus the previous cumulative, frequency. So that's what I was doing here. The same thing I did here. I got the cumulative frequency up to the 4th class minus the cumulative frequency up to the 3rd class, and so on and so forth. So this was the alternative formula I wrote instead of using, because as we saw earlier, the basic form actually isn't working, of the formula is not giving us a correct value, because when we check, we actually get a total frequency which is higher than what we expect. So you can actually plot these cumulative frequencies. You can plot these cumulative frequencies to get what you call an ogive curve. You can plot this to get what you call an ogive curve. So let me just insert something here so we can. It's easy to select the classes. So let me say, let me have the classes here. Let me format this as text. Then I show you what an ogive curve looks like. So this was 0 to 9. This is 11, 10 to 19. This is 20 to 29. This is 30 to 39. This is 40 to 49, right? So if we plot this, should be on a line, right? So this is what you call an ogive curve, yeah. So an ogive curve is actually going to give you the cumulative frequency, which should sum to, you know, to your last cumulative frequency. So this is what you call an ogive curve. It gives you the cumulative frequency. So then the other thing that we should look at for is skewness. So skewness just gives you an idea of where you have, you know, skewness will give you an idea of where you have, you know, the biggest frequency density. Which classes have the biggest frequency density. So in this case, for instance, if you look at this, this is what you call a left skewed data. So this data over here is left skewed. Then this data over here is right skewed. If you have data like this, then this data is going to be symmetric. It has a skewness of 0. Then this data over here also has this one is highly right skewed. If you look back at our data, for instance, if you look back at our data, this data here, if I just get rid of this, so this is our frequency and these are our limits. So if I construct a graph from here, then I'm gonna have, if I get a bar chart, okay, so I have to have this as text, otherwise it's going to try and plot it. So let me just format this as text, because I want this to be categories, right? So if I format, let's see what happens. If I insert, I still try to do it. Let me just if I format it as text, okay, so let me just get these values, get rid of the formulae. So I'm going to repaste as values, then I can format this as text. Then I'm trying to, let me format again. So if I try to format this as text now, is it working? Format, then I want to format it as text, right? Then format, and I want to format it as text. So apparently it claims it is now formatted as text. So okay, it doesn't work. I think the chart is still seeing it as a, you know, I think the chart is still seeing it as numbers. So let's try that. So now let's try and insert, see what comes out. So now we have it. So we can look at our data here and we try and figure out the skewness. So for our data, it's not very easy to understand, you know, the skewness. So we cannot really say if it's right skewed or if it's left skewed. It seems to be a bit symmetric. There's actually a formula for skewness, which is quite complex. You can actually get the number. So the formula, is it given here? So the formula is actually not given here. I think it's given in the next chapter. So I think this brings us to the end of this chapter.